Hello, good morning students. In the last lecture we discussed about the rational numbers, irrational numbers and real numbers. The numbers which can be represented in the form of p by q, where p and q are the integers, are called rational numbers. The numbers which cannot be represented in the form of p by q, where p and q are the integers and q is not equal to 0, are the irrational numbers. Next, real numbers. Real numbers is the collection of rational numbers and irrational numbers. Therefore, real number is either rational or irrational number. Okay. Then we solve exercise 1.2. We completed the exercise 1.2. Okay. So today we are going to start the real numbers and their decimal expansions. Okay. So in this section we are going to study rational and irrational numbers from a different point of view. We will look at the decimal expansion of real numbers and see if we can use the expansion to distinguish between rationals and irrationals. We will also explain how to visualize the representation of real numbers on the number line using their decimal expansion. So first we find the decimal expansion of rational numbers. Okay, so find the decimal expansion of 10 upon 3, 7 upon 8 and 1 upon 7. We know that these three numbers are rational numbers. Okay, so first 10 upon 3. If we divide 10 upon 3, we get 3.333 up to so on. Okay, if we divide 10 upon 3, okay, 3 3s are 9, so 10 minus 9, 1, remainder is 1. Again we get 0, so point, decimal point, again 3 3s are 9, so we get remainders 1 1 1 1 1 and the quotient is 3.333 up to so on. Okay, similarly if we divide 7 upon 8, we get the remainders 6 4 0. Okay, and the divide quotients are 0.875. okay, if we divide 1 upon 1 by 7, we get the remainders 3 2 6 4 5 1, again 3 2 6 4 5 1. okay, and the quotient is 0.142857. okay, we know that how to divide the numbers. okay, आता हे तुम्ही इथं काय केले, डिवाइड करून घेतले. ओके, सो इन द 10 upon 3, okay, the remainders are 1 1 1 1 up to so on 1. okay, and the divisor is 3. Next, in the 7 upon 8, the remainders are 6 4 0. okay, and the divisor is 8. Next, in the 1 upon 7, the remainders are 3 2 6 4 5 1, again 3 2 6 4 5 1, and divisor is 7. So what have you noticed? You should have noticed at least three things. The first one, the remainders either become 0 after a certain stage or start repeating themselves. Okay, the first one is the remainders either become 0 after a certain stage. Okay, so in the 7 upon 8, the remainders becomes 0 after certain stage. Okay, in the 7 upon 7 the remainders becomes 0 after finite number of stage or after a certain stage. Or and in 10 upon 3 and 1 upon 7, the remainders start repeating themselves. In the 10 upon 3 and 1 upon 7, the remainders starts repeating themselves. Okay, so second number, the number of entries in the repeating string of remainders is less than the divisor. Okay, the number of entries in the repeating string of remainders is less than the divisor. So in 1 upon 3, one number repeats itself and the divisor is 3. Okay, in 1 upon 7 there are 6 entries. Okay, in 1 upon 7 there are 6 entries. 3, 2, 6, 4, 5, 1 are the entries in the repeating string of remainders and 7 is the divisor. Okay, in 1 upon 3 one number repeats, that is 3, and the divisor is 3. And in 1 upon 7 there are 6 entries. Okay, 3, 2, 6, 4, 5, 1 in the repeating string of remainders and 7 is the divisor. Next, number 3. If the remainders repeat, then we get repeating block of digits in the quotient. If the remainders repeat, then we get a repeating block of digits in the quotient. For example, in 1 upon 3, 3 repeats in the quotient, and for 1 upon 7 we get the block of 1, 4, 2, 8, 5, 7 in the quotient. Okay, first in 1 upon 3, here 3 repeats in the quotient. Okay, that is 3.33333. So 3 repeats in the quotient, and in 1 upon 7 we get the repeating block. Okay, so 1, 4, 2, 8, 5, 7. Again we get 1, 4, 2, 8, 5, 7. So this is a one block, that is 1, 4, 2, 8, 5, 7. This is a one block. So we get a repeating block of 1, 4, 2, 8, 5, 7 in the quotient. Okay, the remainders are repeat. Okay, in this 1 upon 7 the remainders start repeating themselves. Therefore here the quotient is the repeating block of 1, 4, 2, 8, 5, 7 repeating in the quotient. Okay, on division of p by q, two main things happen. Either the remainder becomes 0 or never becomes 0, and we get a repeating string remainders. Let us look at the each case separately. So there are two cases. The first one is the remainders become 0, and the second one is the remainder never becomes 0. So first one, case 1, the remainder becomes 0. In the example 7 upon 8, we found that the remainder becomes 0 after some steps. Okay, and the decimal expansion of 7 upon 8 is equal to 0.875. Other examples are 1 upon 2 is equal to 0.5, 3 upon 2 is equal to 1.5. Okay, 7 by 2 is equal to 3.5. So here we observe that the decimal expansion terminates or ends after a finite number of steps. Okay, or we get remainder 0 after some steps. So if the decimal expansion terminates or ends after a finite number of steps, then we call the decimal expansion of such a numbers terminating. Okay, in the example 7 upon 8, the remainder becomes 0 after some steps. Okay, and the decimal expansion of 7 upon 8 is equal to 0.875. Also in 1 upon 2 is equal to 0.5. 3 by 2 is equal to 1.5. So here the remainder becomes 0 after finite number of steps or after some steps. Okay, that if the decimal expansion terminates or ends after a finite number of steps, then we call the decimal expansion of such a numbers terminating. That is, terminate means there is the stop. Okay, the remainders become 0 and the expansion stops or ends. Okay, now the second case, the remainder never becomes 0. Okay, in the example 10 upon 3 and 1 upon 7, we notice that the remainders repeat after a certain stage, forcing the decimal expansion to go on forever. In the other words, we have repeating block of digits in the quotient. Okay, for example 10 upon 3 is equal to 3.3333 up to so on. Okay, and 1 upon 7 we answer is 0.142857, again 142857, again 142857. Okay, the usual way of showing that 3 repeat in the quotient of 10 upon 3 is to write 3.3 bar or 3.3 dot on the number 3. ओके, म्हणजे तुम्ही 3.3 लिहिला आणि त्याच्या 3च्या डेसिमल पॉईंटच्या पुढच्या आपण ह्याच्यावरती डोक्यावरती जर बार किंवा डॉट आपण देऊ शकतो. सिमिलरली सिन्स द ब्लॉक ऑफ डिजिट 142857 repeats in the quotient of 1 upon 7, we write 1 upon 7 as 0.142857 bar, where the bar above the digits indicates the block of digits that repeats. Okay, so for in the example 10 upon 3 which is equal to 3.3333. Okay, so we write it as 3.3 bar, the bar above the digit. Okay, or also we can write 3.3 dot, a dot above the digit. Okay, and in the example 1 upon 7 is equal to 0.142857, so we can write 0.142857 bar, where the bar above the digit indicates the block of digits that repeats. Okay, so today we discussed the real numbers and their decimal expansions. So first we find the decimal expansion of 10 upon 3, 7 upon 8 and 1 upon 7. Okay, so in 10 upon 3 the remainders are 1 1 1 1 1 up to so on, and divisor is 3. Okay, in the division of in the decimal expansion of 7 upon 8 we get the remainders 6 4 0. Okay, and divisor 8. And in the decimal expansion of 1 upon 7 we get the remainders 3 2 6 4 5 1, 3 2 6 4 5 1, and divisor is 7. Okay, so we here we notice three things. The first, the remainders either become 0 after a certain stage or start repeating themselves. Okay, so in 7 upon 8 the remainders becomes 0 after some stage or after a finite stage, and in 10 upon 3 and 1 upon 7 the remainders start repeating themselves. Okay, and if the remainders repeat, then we get a repeating block of digits in the quotient. For in the 10 upon 3, okay, 3 repeats in the quotient, and in 1 upon 7 we get the repeating block. Okay, so 142857 is a one block, and this block repeating in the quotient. Okay, then we look two cases. The first one is the remainder becomes 0. In the example 7 upon 8 we found that the remainder becomes 0 after some steps. Okay, so the decimal expansion terminates or ends after a finite number of steps. We call the decimal expansion of such numbers terminating. Okay, the second one, the remainders never becomes 0. In example 10 upon 3 and 1 upon 7 we notice that the remainders repeat after a certain stage, forcing the decimal expansion to go on forever. Okay, so here for example 10 upon 3 we get 3.3333, so we can write 3.3 bar, a bar above the digits indicates, okay, the number repeats. Okay, in the 1 upon 7 we get 0.142857. Okay, so we write 1 upon 7 is equal to 0.142857 bar. Okay, so where the bar above the digits indicates the block of digit that repeats. So all these example give us non-terminating, recurring or repeating decimal expansion. ओके, हे काय सगळे तर हे कशाचे एक्झाम्पल्स आहेत, नॉन टर्मिनेटिंग रिकरिंग और रिपीटिंग डेसिमल एक्सपान्शन्स. ओके, so in the next lecture we will solve some examples on it. Okay, goodbye.